Hi everyone, my name is Zoheb Shaik and I'm cloud native Kubernetes engineer. Have you heard of Kubernetes as a service or control plane as a service or bring your own Kubernetes node? So let me share my screen and then I'll take you through like what I'm trying to convey. Basically, I'm talking about a product Kamaji powered by Elastic. It's a powerful product I can say where we can achieve multiple use cases like hybrid approach, Kubernetes as a service, self-managed Kubernetes service. And let me show you. Yeah, so basically I have a Kubernetes cluster. It's a 3 node Kubernetes cluster. On the top of it I have deployed Kamaji. It's an open source project and it has enterprise support as well through Elastic, and HCD it's highly available, running on a different nodes on a different AZs, and I have deployed tenant control plane TCP, and it is up and running. So the overall architecture is I have a Kubernetes cluster, and on the top of it I have deployed Kamaji, which acts as a management cluster for Kamaji, and I am leveraging Kamaji to deploy hosted control planes like tenant control planes TCP. Let me share another tab so that I can present everything. Yeah, high level architecture of yeah. If you see my screen here, I have two different clouds like Azure cloud on the left hand side and AWS cloud. On the Azure cloud, as I have shown, I have Azure AKS cluster. On the top of it I have Kamaji, and in AWS I have created a basic VM, and I wanted to add this VM to the class control plane hosted on Azure. So this is how we can leverage Kamaji. It's a hybrid approach. We have multiple use cases. For now I just wanted to show you like how it works, and a critical component here is connectivity, which acts as a network tunnel as I'm showing here. It's a basic high level diagram, and let me show you like how we can access. I wanted to SSH into the VM. It's a worker node hosted on AWS. So here is the node, and here are the pods. This is the agent which I'm talking about, which will run on this worker node connectivity agent, and it will connect to connectivity server, and this is how the high level connection happens. The beauty of this product is the console I'll take. This is a control plane, tenant control plane. We can scale and we can create multiple tenant control planes. Like we can scale up to 10, 100 or even thousands, and depends on the requirement and specific use cases. And we just need to make sure like the backend management cluster should have the capacity to host these many control planes. And these control planes are really lightweight, and I wanted to stress specific area. Like in general, if we want to host bare minimum control plane, we need 3 VMs like 4 VCP or 16 GB as a bare minimum. But with this tenant control plane, with this Kamaji approach, this tenant control plane will just run as a pod in Kubernetes. So it's a very lightweight. That's why I highlighted in this diagram as a like lightweight K8 control plane, and the connectivity for as a bridge. So this is like a high level one use case, and I have came across one more use case. It's similar to what I have explained. Like we had a VMware infrastructure, and we wanted to achieve resiliency, consistency, and high availability at control plane as well as worker nodes as well. So I hosted this control plane like HCD across different AZs by leveraging hybrid model like hosting in Azure AKS, and worker nodes, as I highlighted, we leveraged just a VMware. In this case, I just explained about AWS. Even I will show you the AWS node as well, just for clarity. like what I'm talking about. This is the worker node, and the IP is 191, the same IP here. Yeah, the IP of the node, and it is like AWS. So basically we have a control plane hosted in Azure and a worker node hosted on AWS, and the worker node can be in VMware or any data center or any virtualized environment. So it's like a bring your own Kubernetes node, and we can scale this control plane on the fly by leveraging Kamaji and Plastic. We have enterprise grade product. It's like enterprise support we have, where we can get SLA, and we have multiple things like application delivery, monitoring, backup and restore, which will help enterprise organization to adopt a hybrid approach as well as like on-prem approach as well. So if you have any questions or if you have any queries, you can reach out to me over LinkedIn, or I'll try to share this video over LinkedIn if possible, or through other channels. Thanks for watching. For now, this is what I have. Maybe in coming sessions I'll try to explore more about different use cases and how the Kamaji and Classic can bring a real value to the organizations. And one more thing is, if we can use GPU as a service as well, especially SaaS based companies, they are struggling with GPUs. So we can have control planes in one area, and they can leverage GPUs, as I mentioned, like bring your own nodes. So there are so many use cases where Kamaji and Classic can bring value. So that's it for now, and see you in the next session.